Hey everybody, let's give this problem a try. So we want the shear force and bending moment as functions if we cut this somewhere between 0 and 2 meters. Let's also finish the problem by finding the shear force and bending moment functions everywhere, even if we cut it between 2 and 6 meters. First though, we want to solve for the reactions at the supports. So if I call this pin A and roller B, let me decompose the reaction at pin A into X and Y components. Okay, and then we have the roller at B. And there is the couple here. Okay, so now let's solve for those reactions. Okay, so in the X direction, AX, Y direction, some torque about anywhere we want, about over here. Okay, so the torque by this is 6 meters times By, and then the couple is going actually in the negative Z direction, so negative. Okay, so AX is 0, solve this for By, 3600 over 6 is 600. And then AY is negative BY, so negative. And AX was 0. Okay, so we got the reactions. So it looks like AY was negative, right? So I drew my arrow going up. The value is negative, so it's actually this way. And then BY, I drew my arrow going up. This is positive, so like this. And there's the couple right there. Okay, here's the thing. If you cut the beam anywhere between 0 and 2 meters, the left section will always look like this. Okay, and then the right section will always look like this. For any choice of X between, and then this would be 6 minus X, right? For any choice of X between 0 and 2. Okay, before we continue here, what if you cut the beam somewhere between 2 and 6 meters? So between over here and over here. You cut it somewhere over here. What would that look like? Okay, so if we cut the beam between 2 and 6 meters, what would it look like? The left section would look like this. And the right section would look like this. Okay? All right. So let's go back. Which of these two sections would you prefer to analyze, knowing that you'll get the same answer either way? I think this one maybe arguably is simpler to analyze. Okay, so I'm just going to get rid of this to save space. All right, so let's solve for these three unknowns right here. Okay, and the X direction, this Y direction, minus 600 minus V, in the sum torque about anywhere we want. If I sum torque about over here, then the torque from this would be 600 times X. And there's this couple plus. Okay, so this is 0. V is negative 600. The bending moment is negative 600 x. And this is true only for x between 0 and 2. Okay, now what about over here? Which of these two sections would you prefer to analyze, knowing that you get the same answer either way? I think this one looks simpler, so let's ignore this one. Okay, so let's solve for these three unknowns. Okay, x direction, negative, p, y direction, v plus 600. Sum torque about wherever we want. So I'm going to sum torque about over here, the left end. Okay, so then I didn't label, but okay, what is this dimension? The entire beam was 6, right? And then I cut it somewhere between 2 and 6, where this is x, this whole thing was 6, so this is the leftovers, 6 minus x, right? Okay, so the torque about this end would be positive 6 minus x times 600. And then there's this couple in the negative z direction. And there we go. So this v bending moment. You can just leave it like this. So, or you can multiply it through. I mean, same thing, right? Okay, so then this is only true between 2 and 6. And let me just bring these next to each other. Okay. All right, so what does this look like? Axial force is 0 everywhere, so maybe I don't need to graph that. The shear force actually, well, I guess we can graph it, but it's a kind of boring looking graph. The shear force is negative 600. So this is a 246 meters. All right, so the shear force looks like negative 600 between 0 and 2, negative 600 between 2 and 6. So it's just negative 600 everywhere. Okay, what about the bending moment? Okay, so it is between 0 and 2. At x equal to 0, it's 0, and then the slope is negative 600, like this. So that's got to be negative 600 over here, right? And then over here, what happens? At x equal to 2, then we have 3600 minus 1200, so that's 2400. So it kind of jumps up. Okay, so I got the scaling a little off. It's going to jump up to 2400. Like this. Okay, so this was at negative 600, then it jumps up to 2400, and then see the slope right here? It continues going down until x equal to 6, so that's 36. Okay, so then it goes all the way down to 0. Okay, so here we go. That's the bending moment. Okay, so then you, as an engineer, you look at it, all right, the shear is constantly negative 600. The bending moment, though, hits a maximum of, over here, 2400. But then there's this discontinuity, right? It just jumps from negative 600 up to 2400 right at the 2 meter mark. Okay. So give this problem a try. Let me know if you have questions. I'll see you in the next video.